Good morning.
Hello.
Hello, hello.
Hey, I'm here.
Okay, let's wait for another couple of minutes if any other folks gonna join.
Sure. Let me ping Jason to see whether he wants to be here.
Okay. Oh, by the way, G will not join this meeting today.
He cannot?
Yeah.
Okay.
Okay, I think we can get started.
Sure. So yeah, thank you for allowing me to talk about this in short notice. I pretty much decided to talk about this yesterday, mostly because I need to talk with the people working on the containerizer stack. So this seems like a pretty good time slot. I didn't really get too much time to prepare this, although the bug itself has been honestly affecting our cluster for like at least a couple of quarters. We roughly see this kind of happens about every month. But it's not mentally occurring. It just kind of keeps accumulating, and eventually it renders most of the GPU machines in our cluster unusable. And we massively restart the Mesos agent on all of them. The symptoms disappear, and then after a while, they slowly come back, and they got pinged again. So this time we were a little bit lucky in the log analysis, and I found a very good correlation with the problem. Also, let me explain the problem first. The issue we observed here is that it seems like there is some logical possibility that the NVIDIA GPU isolator kind of leaked a GPU card that previous allocated. That is why we see the log lines like collect, fail, requested 1, but only 0 available. The 1 there is the number of GPU devices isolator thinks it has, because the agent thinks the isolator has, and they're asking it to allocate. But the isolator itself cannot allocate anymore because there's only 0 available. So this prevents any container with a GPU card being properly provisioned. We have even seen sometimes say requested 2, but only 1 available. Even that kind of thing has happened. But anyway, in last episode, which is roughly, what is it, Wednesday? I think it's on Tuesday. We analyzed the logs in our cluster, and we found a very good correlation in our cluster. By the way, this is not my log. This is the log of original bug reporter. But if you scroll down to the bottom of the comment, the bottom of this task, I saw this line. Termination of executor something of framework failed to kill all processes in the container, timeout after 1 minute. And if you click on the next line, the to-do link there, the previous author, I believe is Yin, actually acknowledge that this condition might be problematic because we are short-circuiting all the isolator cleanup in this case. So it seems like there is a pretty strong logical explanation here in that the containerizer was not able to, the launcher was not able to terminate all the processes in this container within the timeout, and then the containerizer decided not to call any isolators cleanup. The cleanup method. The GPU isolator is designed in a way that the cleanup method really needs to be called, so previous allocated GPU card can be deallocated. But if that's never called, this GPU card is kind of logically leaked in this allocation process until the Mesos agent is restarted. If we restart it, then the recover process of the isolator is able to fix all the problems. That's yeah.
Is this always happen when after you kill the executor? I
honestly don't know whether we were killing the task or whether the task itself is having problem and terminating, but it seems like there are certain cases that the process in the container are not able to fully terminate within 1 minute.
I see. So the issue here, it is you guys get the destroy failure because you cannot kill the container process in Linux launcher.
I mean, the destroy failure is not great, but this is actually not a big problem. I guess this at most translates into a strange error message in our stack. The real problem is when a different task, a later task, uses GPU got scheduled on the agent. That's where the real problem happens.
I see. So you're saying the Linux launcher could not kill a container process. So the old container still hold the GPU resources, but Mesos think that single one GPU.
I don't think that's the case. I think the old process eventually died, and the new process could able to use this GPU card. The problem is that the GPU isolator the cleanup function of GPU isolator never got called. And the
I
GPU
see.
isolator did not know it can deallocate that GPU card. Did not know it should deallocate that GPU card.
So you mean the isolator cleanup is not called for the old
Yes.
container?
For the yes,
And-
for the first container.
But
If you look at that,
okay,
to
okay.
do
So it makes sense. It makes sense.
Yeah.
So because if you fail
Mhm.
on launcher destroy. So the way we destroy a container, we call launcher destroy, and then we call isolator cleanup, and then we call provisioner destroy. So if you return a failure, which is soft circuit, and then we will return a failure for the destroy, and you will no longer clean up the resources in the isolator. So I think right now we need to the problem we need the issue the way we resolve this issue, we need to figure out why the launcher fail. It might be because basically I don't expect it fail, and I'm thinking two potential reasons. One may be like, one is that like if a container process using GPU resources, and then
Hold on. Let me ask a question. If we use both GPU isolator and other isolators, and if other isolators report generating problem in either the provision or isolate method, would that cause the launcher to fail this container?
I don't understand. Could you rephrase?
So if we I mean, these machines use both the GPU isolator as well as a couple of other isolators. If the other isolators report failed provision method, does that cause the issue you described?
Yes, potentially, because we call the isolator cleanup one by one. So only after one isolator finish cleanup, and then if you move to the other, there's dependency. So
but if any of the isolator failed on the cleanup, other isolators cleanup may not be called.
Depends on the order. Depends on the
order. But if the effective order something earlier, the cleanup of the isolator A failed, the cleanup of isolator B may not be called.
Yes, but you can see the error message. Did you see the error message from the agent log?
I screw up on log backup again, so I didn't got all the logs related to this. But the one thing I actually observed is the whatever the isolator that managed the host path was reporting an error in one of the logs saying that this is trying to mount a non-existing host path. So it is possible that the first container launch failed because it's trying to mount a host path that do not exist.
What version are you guys using?
From Jason that wants to do something there.
So it is Mesos 1.4, right?
Oh, we are running 1.5. This machine is running 1.5.
Okay, so if I remember correctly, so we have an order of isolators to call prepare, and then we use the reverse order for the isolator to do the cleanup, which means I forget whether or not we put the host volume support as a separate isolator and then move it out from the Linux isolator. So we need to identify the host volume is among first, or we do the GPU isolator cleanup first. So it might be possible any failure of other isolator will block the GPU isolator from cleaning up. So why do you guys have the mount point?
It's because these mount points are actually NFS mounts prepared, created out of bound. But occasionally the Puppet code which runs these NFS mounts got failed out of bound without method agent explicitly knowing that. And then these FS mounts are not visible on the do not present on the host, on the agent host. And then, but our user who creates these containers using those FS mounts wouldn't know that. They will just try to do a host path, mount a host path into the container, and these host paths end up not existing on the machine.
So just how I'm confused here. So for this executor, is it the first container you?
It is it's the first container. It's the earlier container.
So one question. So if you fail on launcher destroy, we will not call any isolator cleanup, right?
Well, actually, I don't know. Launcher.
So how do you get the host volume on mount failure?
Okay, maybe that's unrelated. Are you suggesting that might be unrelated?
Because if you get any isolator cleanup failure, we will print out in agent log. You're supposed to find those failure message.
Okay.
Oh, Jason.
So, Gilbert, let me ask you this question. Are the mount are like all of the host mount isolators and things? Are they ordered after the GPU isolator? I forgot the exact order, but I think there's a order, right?
So in 1.6, I think in 1.6, we have a default order of the isolator, and all the custom module they're gonna be ordered after the all those building isolator. So if you go to the containerizer create method, you can find the right order for those isolator. And we Jens Pitch did some refactoring in 1.6. So it is 1.5. We need to go back to the right version of Mesos, but they are in some specific order. And GPU isolated, there are some dependency for GPU isolated. So
I remember the dependency was mostly about device management.
It depends on Linux file system isolator for sure, because we need to make the sandbox path as a share mount, and we also need to create a separate mount namespace. So basically, the GPU isolator, it depends on those two from the Linux file system isolator, but I forget at which position it located, but it do have some dependency. We need to double check on the 1.5 version.
Okay.
So I think for this issue, I don't know whether you guys see the error message from other isolator cleanup, but the thing I would like to make sure it is like, if it is stucking at launcher destroy, and you guys should not see there will be no isolator cleanup be called. So we need to figure out why we fail to kill the process. So if it is stucking at any host volume on mount, and then we will still see those message, and then we need to understand, is it related to NFS mount? And we need to figure out. So I don't, basically for this issue, we need to spend more time to do the charging and then collect more agent log. Do you guys have any like consistent way to reproduce it?
No.
It is always occasional.
This happen widespread of happening this roughly every month. It is not monthly, but sure, it's kind of like, it seems like, I don't think it's evenly distributed. It seems like occasionally this happens on one of the machines, and then quickly, like within a couple of hours, we see maybe half of the class. So within a couple of hours, I'll say. Within a couple of hours, we see about 50%, around half of the clusters, machines in just randomly starting to seeing a similar problem, and then eventually cluster is not.
So another hypothesis, it is like, if any container process which consuming GPU resources, will it be using more time to kill the process?
It's possible. These are very big process with a lot of low-level system code and very heavy. Yeah.
Yeah, I think
they tend to behave more crazy than regular HTTP services, which we are more experienced dealing with.
Yeah, and this is totally up to your environment, I think. And I forget whether or not this is the timeout, which is configurable or hard-coded.
So I think we also previously saw problems with zombie state. Jason called zombie state, right?
Yeah, it's not zombie state, but like the disk sleep state because
yes, disk sleep state. Yeah. Previously, in these clusters, because we also use NFS, occasionally some process fall into this nasty disk sleep state, which is not even killable by CQ.
Yeah, so like when it's stuck in I/O or having like some of the Fuse or NFS file system is having issues or bugs or whatever, and those containers are not killable.
And if those containers are not killable even by a SIG kill, it's possible that the destroy cannot finish within a minute, and then we still consider task is. I think task is dead, terminate in terminal state. But then we tell the pretty much the issue here is that containerizer tells agent tells the entire resource allocation stack master scheduler that the previous task is terminal, so you can schedule new things. And the system decided to schedule new things, but the GPU was not freed up.
That's reverse actually.
Mm-hmm.
Okay,
that's
so
the second container, yeah.
So right now the assumption was like any other like NFS bug or any other I/O issue which might cause the queue system call failed or pending or stacking. Mm-hmm. So Mesos could not kill a container process. Mm-hmm. And you guys, I think initially I expect we could find the root cause from even if it's from the other component, we should find the root cause, or maybe a bug on Mesos side. And instead of like go ahead and adding some retry logic, I think we could consider that for sure, but we should definitely understand what's the problem.
I don't object on that, but what I want to discuss here is just confirm some design principles here. Say, do we kind of expect we will be reliably terminate any process in a container? So we know that cleanup should always be called. That seems like honestly a little bit dangerous design principle, because a lot of things it's difficult to assume these things can always be reliably called, reliably finished.
Like the 1 minute timeout, like 1 minute timeout thing. It feels like there's no room to configure it. That's point one. And also, if you cannot do so for any particular reason, serving all of the heterogeneous like workload, and think there should be some sort of error being emitted and being carefully tracked, so people can take note.
Jason, there is an error being omitted. If you see the block, the retry, the line right above retry, that emits a counter.
Yeah,
we can monitor that counter for sure. We're actually probably going to do some temporary remediation. If we see that counter, we just restart Mesos agent from system D. We are considering that approach in-house, but I don't think it's a scalable solution.
Yeah, I think that's totally up to the operator. That's an option for operator to consider. But basically, I never see this error message before, and I suspect it might relate it to some internal kernel workload, and I did not see where the timeout it is. I think this might be a default timeout from a system call.
Yeah. So actually, if you ask me here, the fact that agent cannot kill this process within a minute is not that a big deal to us. If say the agent kind of retries with some kind of interval and eventually manage to kill it, that's okay in our stack. what's really bothering us right now is we give up retrying this after the first failed attempt, and then some piece of resource got leaked.
So Zhitao, I understand your motivation on like resolve this issue, but do you feeling like adding retry it is just a workaround? We still don't understand why it failed. We need to. I think we could consider that option, but we need to like figure out what's the root cause.
Okay. Well.
Yeah, I think right now we don't have enough.
Honestly, we are a bit lucky in the sense that we can access people's code. There will be operators who don't even have access to the code people running in the container. It's going to be even harder for them to figure out what went wrong, unless we have high confidence there's only one way to lead into such issues, which I kind of doubt it. With the different combinations of Linux kernel versions, file systems, different things where different type of devices we could be using by the system.
So are you able to reproduce this issue in your?
I was never to actively reproduce it. It's just like this issue keeps showing up in our cluster. Yeah.
So you never reproduce this issue?
I'm never able to say submit a task and getting this reproduced correctly myself.
So since the last time you hit this issue in your cluster, did you collect the host mount table and the process information to confirm the container process is already gone? Did you?
I think we can do that when it happens next time.
Yeah. Actually, this is the first time I starting to focus on the incorrect termination of previous container. We were not looking at this previously. Our hypothesis was about internal bug of the GPU isolator itself. So we were focusing our limited attention there, and we couldn't really find any log that backing those assumptions. So that's why, and we have to recover the cluster quick because our customer wants to use the GPU cards. This is the first time we starting to focusing. This is the first time I saw the log that indicates this may actually coming from previous containers. Yeah. Also, another thing is, for example, if the previous container got incorrect termination, but nobody submitted a task on this machine for 6 hours, then in the 6 hour in the middle, there's nothing showing up in this. There's nothing that indicating something could go wrong later.
Okay, since we already cleaned up the freezer SQL for this container. Hey, Zhitao.
Yes.
So what's the proposal here? So you guys still want to go ahead?
I'm not officially proposing anything right now. I think we can probably tolerate one more episode of this and collect more logs next time. And if you have hints about what things we should focusing on, can you comment on the task? Say if whoever wants to root cause on this one, what other signals we should try to collect before we make any change to correct the system?
Yeah, sure. I'm thinking if we could add more logging message, which might be helpful to collect more debug information. And
I can try to upgrade 1.6 to rule out the other problems here. We do have that plan anyway.
Because personally, I'm kind of don't want to go ahead and without knowing the root cause and then go ahead and add the retry logic. I think it is like some random choice we expect, and it might happen that all the retry fail if we don't understand what's the root cause. So would you guys mind keep watching, and once you get an alert, try to collect collect the running process ID and to see if the old container.
The thing is, this is an annoying part of this bug. Actually, our bug reports are received at least after the later container shows up.
Mm-hmm.
We never knew there was a container launching that actually failed. Let me say, sorry. Let me correct myself. We were never focusing on the failed destroy. And our users specifically rarely care about that. Nobody was monitoring that stat. So if we do that, we would probably need to deploy some infrastructure, say, run some utility scripts automatically when the container destroy error happens.
I see.
Yeah.
Okay.
And it's possible, but we don't have that infrastructure in-house right now.
Yeah, I understand. So the operator may not know this issue.
Yeah. If you have suggestion on whatever logs that we can pay extra attention to, or we can definitely focus on that, and then we can add verbose loggings and turn on certain logging there.
So one more question: is this issue happened recently after any upgrade, or you guys have always seen this issue?
We have been receiving bug reports on this pretty much as early as beginning of this year, if not even earlier.
So you mean since the beginning of you guys run workload on GPU?
Kind of, yes. At that time, the cluster was running 1.1. Later, we upgrade 1.5. The issue are still there.
So did you guys use NFS since the beginning?
Yes.
And
we've been using GPU and NFS from very beginning.
Okay, and then you guys have this issue since the beginning. Okay. So would you mind also like let me know how you guys use the NFS for Mesos? Is it for all slave there?
No.
So those are for like the data crunching, and also there are a lot of data shared between like in the cluster. So yeah, I mean that's a really required use case, and we cannot easily get rid of.
No, I'm not asking you guys to get rid of NFS. I'm just trying to understand. So how you guys consume it?
So the NFS amounts are mostly, so previously we were loading both executables and the data for a lot of workloads similar to machine learning training. It may not be technically machine learning training, but kind of pretty similar code like offline data processing pipelines. The code actually load both executable as well as the data from NFS and execute them. Recently, some other engineer is moving our cluster to a model, say, executable binaries will come from the container image, and only data may be coming from the NFS. But even, I don't know whether that's fully converged yet. But the number of NFS mounts we need to use in the process did not really change. We still mount the same amount of NFS mounts and load things from there. Okay. So we are going to be stuck on NFS for at least, my estimate is about at least a year or two.
Okay. Since that we already called the SQL cleanup, we already cleaned out the freezer SQL for this container. So yeah, I need more time to help on this issue because I don't think it is something I could find the root cause in short term. But let's sync up continuously.
If you have thoughts, feel free to comment on the bug. It seems like at this point, the bug we can say it's likely this thing is related to either containerizer or the internals of the isolators, which is kind of internal to the containerizer. Yeah. So we can focus previously I was working with Ben Moller, but he's not that familiar with the internal of the containerizer yet.
Okay. Yeah, it might be something in the Linux launcher, and we might want to Yeah, I'm not sure it is a timeout issue, but I need to spend some time on that.
Sure.
Yeah, let me add an action item for.
We'll try to put more monitoring in our stack, so see if we can catch the issue more aggressive in an earlier time and monitor things and do a bit better analysis there and see if we can provide more information.
Okay.
Mm-hmm.
Seems like serious enough for you guys for production.
Yeah. Yeah, I think this seems like the biggest problem in our GPU cluster.
Mm-hmm.
Yeah, other than that, there isn't too much complaints so far.
Okay. Okay. So
Okay.
yeah. So definitely I need to spend more time on this one.
Yeah.
I think debugging might not be able to be finished during the working session.
Yeah, I probably will. Okay, it's currently assigned to me. That's fine. Yeah. Okay.
Yeah, we can cooperate on this issue.
Okay.
Any other agenda item folks would like to discuss? No? No? Okay, so I guess we can save in 23 minutes. And thanks for joining the working group meeting, and I will see you guys in 2 weeks.
Okay.
Sure.
Thank you.
Thank you.
See you guys. Bye.
Jason, are you still there?